Welcome to Get Your FRQ On. This question is from 2005, Test B. It's question 6, and it is not calculator active. In the question stem, we are provided with a differential equation. In part A of the question, we are asked to sketch the slope field at the 12 points provided. First thing you want to do is use that differential equation to find the slope at the given points. Once you have the slopes, sketch the slope field. One thing you will always want to do with a slope field question like this is analyze the differential equation. Notice that when either x or y is 0, dy dx is 0. So anywhere on the x-axis, anywhere on the y-axis, the slope will be 0. That should be easy to do. That's 6 points. That's half the points on the graph. And then just do a little bit of arithmetic to find the slope at the other 6 points. And you get a slope field that looks like this. In part B of the question, we are asked to write the equation for the tangent line to f at x equals -1. We're provided in the question stem that f of -1 is 2, and we can use -1 and 2 in the differential equation to find the slope when x is equal to -1. So use dy dx to determine the slope of the tangent line at the point -1, 2. If we do that, we ultimately get to the opposite of -1 times 2 squared is +1 times 2 squared, which is 4 over 2, which is 2. Now that we know the slope of the tangent line, we can write the equation for the tangent line using point-slope form. You can write this in any form, point-slope form, standard form, or slope-intercept form. It just has to be correct. I usually use point-slope form because once you have a point and the slope, it's the easiest equation to write, and you don't have to simplify it anyway, so you might just as well use the easiest one to write. And we get the tangent line is the line y minus 2 is equal to 2 times the group x plus 1. In part C of the question, we are asked to find the particular solution y equals f of x if f of -1 is equal to 2. To do this, we're going to use separation of variables, as would be expected on an A-B free response question. Typically, if you have to solve a differential equation in a free response question on the A-B exam, at least, you would be expected to use separation of variables because it's pretty much the only method that you learn to do this. In fact, not using separation of variables when it is expected could be very detrimental. It can cause you to fail to earn a lot of points on a free response question. So if we start with our differential equation, dy dx is the opposite of x times y squared all over 2, and separate the variables. We get dy over y squared equals -1/2 x dx, and then we just anti-differentiate both sides. After anti-differentiating both sides, we get -1 over y is equal to -1/4 x squared plus a constant. All right, using that initial condition, f of -1 is equal to 2, we can solve for the constant. -1 over 2 is -1/4 times -1 squared plus a constant. Simplify everything, the constant turns out to be -1/4. All right, now we can rewrite this, our particular solution using the value of c we just found. So -1 over y is -1/4 x squared minus 1/4. Solving for y, we would get 4 over y is equal to x squared plus 1. Basically, we're just multiplying both sides by -4. That cancels the denominator and the negative sign. It accomplishes quite a bit there. And then solving for y, we get y equals 4 over x squared plus 1.